This is lesson 4, chapter 8, and the title of this lesson is Volume of Prisms. Okay, in the first lesson of this chapter, we talked about the circumference of a circle. In the second lesson, we talked about the area of a circle. After that, we discussed areas of composite figures. Now it goes back to the essential question, how do measurements help you describe real-world objects? And in this case, now we are going to be talking about volume of prisms. That means how much a particular, uh, let's say, container will hold. If you have, for example, a shoebox, how much will it hold? And that is a good example how real-world objects are related to what we're doing in this particular lesson. Okay? So, again, the two things that we will learn are volume of rectangular prism and the volume of a triangular prism. Now, let's recall what we know about prisms. We know that it is a polyhedron with two parallel congruent bases. The bases of a rectangular prism are rectangles, and the bases of a triangular prism are triangles. Now, let's review again which of these two figures is a rectangular prism and which one is a triangular prism. Now, if you look very closely at the first figure, we know that this particular prism has two bases, and the two bases are shaped like rectangles. So this is a rectangular prism, okay? In this particular prism, we have two bases that are shaped like triangles. That's good enough. There. And this one also is shaped like triangles. And just like the rectangular prism, these bases are parallel to each other and congruent. So this is a triangular prism. Okay? So that's just a review about prisms, rectangular and triangular prisms. Suppose you observe the camping tent shown from directly above. What geometric figure would you see? Just like what we talked about, if you look at this from above, you will see something like this, okay, which is a rectangle. So if you look at it like from above, that's how you will see it. This is probably where the line will be in the middle. Oops, not that straight. So this is a rectangle. Okay? So what formula would you use to find the area of the figure? Again, we know that the area of our rectangle or a parallelogram is base times height. And with the rectangle, base times height, our base is our length and our height is our width. So it's length times width. Okay? So that's how we find the area of that particular rectangle. How is that related? Because now we are going to find the volume of our rectangular prism, and take note that we found the area of our rectangle there, okay, which is the same thing as our base, okay? So to be able to find the volume of our rectangular prism, okay, it is the product of the length, the width, and the height. It is also the area of base, capital B this time, times the height. Okay? So in symbols, this is what the formula for volume is. Length times width times height, or volume equals capital B times H, where B is the area. Okay? This is the area of the base. And if you notice what we did in the real world link, okay, we found the area of the base of the rectangle, which is length times width. That's what we found when we did the real world link. Okay? So one more thing to remember, that when you want to find the volume of any prism, it is always that general formula of base or capital B times height, where capital B represents the area of the base of the prism. Okay? in a model, this is how it looks like. Okay, this is your rectangular prism. Again, this is our base, okay, of our rectangular prism, and we know that is a rectangle. Now notice again that that area or the area of the base is length times width. Okay, so your area of the base is the same as the area of your rectangle. Okay, let's move on. Okay, so remember the general formula for volume is always capital B times H, or base times height, where capital B represents the area of the base. Okay, let's take a look at some models here. So the volume of a three-dimensional figure is the measure of the space it occupies. Okay, it is measured in cubic units, such as cubic centimeters, cubic inches. What this means simply is that when you talk about volume, you're measuring the number of cubes that can fit into your polyhedron. Let's take a look at this polyhedron. For example, this is our rectangular prism. So if we want to find the volume of this rectangular prism, we need to look at the number of cubes. Okay, those are the cubes that will fit in this particular polyhedron or in this particular prism. So if you notice, there is already one level of cubes, okay? And one level is equal to 36 because there are 1, 2, 3, 4, 5, 6 cubes on this side, 6 cubes on that side. So therefore, this will be 36 cubes in all. So we need one more layer. So the total volume of this rectangular prism will be 2 layers of cubes, 2 layers of 36 cubes. So therefore, if I count the number of cubes that fit into that prism, that will be 72 cubes, or in this case, 72 cubic centimeters. Since there are 2 layers of 36 cubes to fill the box, the volume is 72 cubic centimeters. Simply saying that there are 72 1 by 1 by 1 cube in each, in this particular prism. Okay? All right, let's take a look at some examples and let's see how the formula works. So you have a rectangular prism. Okay, so in this case, we can label the length as 5, we can label the height as 3, and the width as 4. Okay, if that's the case, we write down the formula for a rectangular prism, length times width times height, and we know our length is 5, our width is 4, and our height is 3. Now, can I interchange these numbers? Of course you can. Okay, because multiplication is commutative, I can make this my height or my width, okay, and so on and so forth. So I can interchange the values of length, width, and height. Multiply all three, I end up with, okay, 60, 5 times 4 times 3. So the volume of this particular rectangular prism is 60 cubic centimeters, or 60 centimeters cubed. Okay? Do the got it problem letter A, and let's see if you understand example number 1. Let's take a look at the volume of a triangular prism this time. Again, the triangular prism, in words, the volume of a triangular prism is the area of the base times the height. Okay? Again, we go back to the formula capital B times H, the general formula for volume, where B is the area of the base. So when you talk about the area of a rectangular prism, the base is a rectangle. That's why it's length times width, which is the area of a rectangle, times the height. Let's go back here just to make sure right here. So this is the area of the base, length times width, times the height. So in this particular case, we want to find the area of the base, and since this is a triangular prism, okay, the base will be a triangle. So this is now our triangular prism. If you notice, this is our base, which is shaped like a triangle. And let's see this, okay, using our cubes. So the diagram below shows the volume of a triangular prism, this one right here, okay, is also the product of the area of the base and the height of h of the prism. So this is our base. After finding the area of our base, we simply multiply it by the height. Okay? So if I'm going to write down the formula for area of a triangular prism, I first write down the general formula of base times height. And we know for a fact that the base is also the same as the area, okay, of a triangle. Oh, that's wrong spelling. And we know that the area of a triangle is 1/2 base times height. Okay? Remember, this is the height that we're talking about here when we're talking about the area of our triangle. Okay? So that's the area of our triangle. That's the height of our triangle. This is the height of our prism. So let's call this height 1, which is the height of the triangle. Let's call this height 2, which is the height of our prism. Okay, so there are two heights here. Okay, so if I am going to write a formula for area of our triangular prism, it's going to be equal to 1/2 times the base times the height of my triangle, and I'm going to multiply it with the height of my prism. Okay? Okay, now let's take a look at example number 2. So find the volume of a triangular prism. Again, we go back to the general formula of base times height. We also know that in this example right here, this is our triangle that we're looking at. Okay? And in that triangle, our base is equal to 6. This is our base. And this is our height 1, is 8. So that's the area of the triangle in red. Okay? We go back to the general formula of area. We will replace now capital B, which is the area of the base, with 1/2 times 6 times 8. Okay? Which is now the same as the area, the general formula for area of a prism, which is capital B times H, base times height. So when we do that, this now is our area of our triangle, which is the area of our base, 1/2 times 6 times 8. And this is the height of our prism, this one right here, which is going to be 9 feet. So it's 1/2 times 6 times 8 times 9. Do your multiplication, you end up to 216. So the volume of this particular triangular prism is 216 cubic feet. Okay? Now, you can actually use the formula that I gave you right here to go straight away and skip the other steps and go to this step right away. Okay? Because this becomes our base 1. This becomes our height 1, and this becomes our height 2. Okay? And that's how you find the volume of this triangular prism. Do the God problem letter B, and let's see if you understand example number 2. Remember, you can use this formula as well for the Goded problem. Okay, let's take a look at example number 3. Which lunchbox holds more food? So this is a good example of a real-world example situation. Okay, in terms of choosing a lunchbox, especially when you go back to school next fall. Okay, you want to find out if you are planning to bring a lot of food and you're choosing between lunch boxes, which lunchbox holds more food? So you have lunchbox A and lunchbox B. Okay? So when we want to find out or compare the two lunch boxes, we need to find the volume of each. And then after that we need to compare their volume. Let's take a look at lunchbox A and lunchbox B. So in lunchbox, since we know that both are rectangular prisms, we follow the formula for a rectangular prism, which is length times width times height. Okay? And let's label our length. This is our length for lunchbox A. This is our length for lunchbox B. This is our width. This is our width. And this is our height right there. So if we substitute the values now for lunchbox A, we have 7.5, okay, times 3.75 times 10, which is the height. For lunchbox B, it's 8 right there, times 3.75 times 9.5. Okay, multiply all three. For lunchbox A, you'll end up with 281.25 cubic inches. For lunchbox B, you end up with 285 cubic inches. Now, if you notice, lunchbox B will hold more cubic units or more cubes inside its lunchbox. So, lunchbox B will hold more food. Okay? All right. So, do the last word problem. Let's see if you understand example number 3. And that's the end of our lesson. Thank you for watching.